in this final lesson, what we're going to do is explain how science has influenced our philosophical positions on free will. So, we talked very, very briefly in the last lesson on hard determinism that science might have maybe have some answers to us, for us, shall we say, when it comes to the concept of free will. So, whenever we discuss free will and determinism today, okay, in the modern period, we have to make reference to science, because science has unveiled some kind of theoretical understanding of how we can explain free will and determinism. So science has contributed to free will in a number of ways, and we're going to discuss the ways in which they are contributed in this lesson. We're going to look at the role of physics, we're going to look at the role of physics quite broadly, and then we're going to specifically home in on the concept of quantum physics or quantum mechanics. We're going to look at the influence of genetics, and we're going to look at the influence of neuroscience. So let's begin with the influence of physics. And just as quite a prerequisite here, just a reminder, that this isn't actually an in-depth physics lesson. What this is going to be is explaining to the best of my ability how some kind of concepts in physics that are quite easy to understand have influenced our understanding of free will. So you won't feel out of your depth at all. So early understandings of physics describe the world as inherently deterministic. So classical Newtonian understandings of physics will describe the world as quite deterministic, because Newton, discovered a number of things about classical mechanics that if I was to, for example, push a pendulum, we know what is going to happen. We know that it's going to swing, and we can work out based on the velocity that I push the pendulum, how fast it's going to swing, the distance it's going to go, and how long it's going to swing for. All of these different things that we can work out from an initial point. Another good example is what we call Laplace's demon, whereby Laplace argued that if someone was able to know the precise position and momentum of every particle in the universe, they would be able to predict the future. Because the concept in classical mechanics is that particles, if you know the initial state of a system and you know the conditions in which the system operates, then you can predict quite accurately the end state of this simulation. And this is fundamentally deterministic. It means that if we can predict the future based off conditions that we have in the present, using our understanding of classical mechanics, then we can say that the universe is fundamentally deterministic. We can determine what's going to happen in the future. However, this might be true of classical mechanics, and if you ever do a physics problem, you will be able to, a classical mechanics physics problem, then you will understand that this is true of classical mechanics. But is this true of quantum mechanics? Because quantum mechanics is something completely different. According to, for example, Heisenberg's uncertainty principle, which is a principle in quantum mechanics, you cannot know both the precise location of a particle as well as its precise momentum. The more you know about the momentum, the less you will know about the location, and vice versa. So this really means that the concept of Laplace's demon, where he suggested that if you know the exact position and the exact momentum of every particle in the universe, then you can predict the future, that is fundamentally impossible to do. So to what extent really can we predict the future? So ultimately, quantum mechanics makes Laplace's demon an impossible conundrum to solve. Moreover, in quantum mechanics, it generally challenged the traditional view of free will when it comes to physics, the concept of deterministic universe. Because quantum mechanics, the way quantum mechanics really operates is you predict things in terms of probabilities. Okay? So when it comes to quantum mechanics, by the way, as a prerequisite, quantum mechanics is the study of atomic and subatomic particles. It's the study of the very, very small, effectively. And when we get all the way down to these very, 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 very small minutiae of physics, then we find that a lot of really strange things start to happen. particles don't always behave as particles but should behave. They don't move as particles should move. The way in which we predict where a particle is going to be isn't in terms of what we know where it begins and where it's going to end up, but we predict it in terms of probabilities. So an electron, for example, a very good example of this is the concept of quantum tunneling. So if you had an electron on one side of a wall, let's just say, okay, and we want to predict where it's going to end up, you have to use probabilities, and there's a high probability that it's going to end up on this side, high probability of end up somewhere else, but there's also a high probability, or at least a probability, that it's going to go through the wall and end up on the other side. And it's these kinds of really crazy quantum mechanical theories that really cast doubt to our deterministic universe, because it's impossible to determine where this electron is going to be precisely. You cannot precisely know the specific location of an electron, because at that point we won't know anything about its momentum. And to get to a 100% precise understanding anyway is impossible in the first place. So all of this casts doubt on our concept of the universe being deterministic. We can only predict things in terms of probability. So in that case, the world cannot be deterministic. We cannot tell the future or predict the future. There is a certain sense of a randomness within the world. Moving on into biology, we also have the influence of genetics. So the question of free will has been questioned by biology as well, specifically in relation to genetics. The most famous example is the debate of nature versus nurture. Don't forget, we looked at this when we were looking at soft determinism and libertarianism early on in this course, because humans are naturally genetically wired to seek out certain things, to seek shelter, to seek food and drink, to seek sex, all of these different things. So with that being said, how much does our genetics determine our free will, our actions, our ability to make decisions? Many researchers found that many human behaviors can be explained in terms of humans' brains' genes and evolutionary histories. So we can't explain human behaviors through just natural free will. We have to use concepts such as genetics and evolution and our brains. So again, this raises questions about whether or not we're even responsible for our actions. And really, if our genetics do determine our behavior, or even our environmental, our environment determines it, how much can we be responsible for our actions? Now, this points us towards a soft deterministic landscape, a soft determinism, because while genetics does argue that there are certain actions that people partake in that are effectively hardwired to our biology and would be described as deterministic, but genetics cannot explain why I, for example, choose to drive to work rather than walk, for example, or choose to do this rather than that. Genetics is a little bit genetics can concretely define some aspects that are determined but not others. So it points to us being more of a soft deterministic. It points to the idea that, well, some aspects of our existence might be determined while some aspects might be free. Neuroscience also has a role to play when it comes to the influence on free will. So with the development of modern neuroscience, being able to look into the brain and understand our brains a lot more, it's become possible for us to study brain activity in a lot more detail. The most famous example of this comes from Benjamin Lebet from the 1980s. And these are what we would describe as the Lebet experiments. Okay, so let's explain what these experiments were. Each subject would be asked to choose a random moment to flick their wrist while being measured by looking at the brain activity. So they've got an EEG machine on or something very similar, and they are told to flick their wrist at a random moment. They're also asked the subjects to keep an eye on the second hand of the clock in order for him to be able to determine when the subject felt the intention to move. So the subject would look at the clock, keep an eye on the clock, and then they will flick their wrists at random points. And then when they made the movement, they informed the time on the clock when they first felt their conscious intention to move. So they didn't just tell the researchers when they flicked their wrist, but when they first wanted to flick their wrist. Okay, so normally a couple of seconds or maybe half a second before. So it was found that the subject's unconscious brain activity would begin around half a second before the subject was actually aware of the conscious intention to move. So let's just break this down a little bit. So let's just go over it again as well. So subjects were sat in a chair with something connected to their brain to measure their brain activity. They were told to watch the clock and to flick their wrist at a random time. And then once they did this, they were told they would then go and tell the researchers when they first had the urge to want to flick their wrist. So usually a little bit before they actually went and flicked their wrists. What was discovered was that their brains would light up around half a second before they said that they were going to flick their wrist. So what this is suggesting is their brain unconsciously activated the desire to flick their wrist before their conscious intention became aware to them. So if that makes sense. So basically their brain would light up about half a second before they said they came up with the thought to flick their wrist. So what does this actually mean for free will? I know that was quite convoluted, but what does this actually mean when it comes to free will? Well, this experiment suggests that our brain makes decisions on how to act before we can consciously recognize. This may suggest that at least some of our decisions are not made consciously. So don't forget that some would argue that if we are making our decisions unconsciously, then it's not our actual free will. So for example, if you accidentally touch a hot stove and you jolt, and it's your quick reactions that jolt away, that's not really a conscious decision. That's not even a decision that even reaches the brain. It reaches the spinal cord. So that is not really a conscious free decision, and so therefore you didn't really have the free will to make that decision. So this experiment suggests that there are some decisions that originate in the subconscious, in the unconscious brain. So to what extent are these decisions to flick the wrist even conscious in the first place? Or at least not just the decision to flick the wrist, but the decision of what time they're going to flick the wrist. This experiment has been challenged by others. So we've got people like Adrian G. Gudisberg here. However, at the same time, this is beyond the scope of this course. So I wanted to try and explain this in as little detail as possible, just to try and get across the concepts of free will that is present in these examples. So the task for this lesson is to look at the following question. Has what you have learned in this lesson influenced your views on free will and determinism? Has it shifted your position? If so, why? Effectively. So I assume that throughout this course you have developed a position of your own. You develop an understanding of your own when it comes to the free will. Maybe you're a libertarian, like maybe you're a soft determinist, maybe you're a hard determinist, maybe you're something in between all of those things. Has the influence of science, have the scientific theories that we've looked at shifted your position in any way? If it has, explain why and to where. If it hasn't, explain why as well. And I hope you've enjoyed this course. We're gonna there are a few problem questions for you to look at in the discussion, in the project section, to try and bolster your understanding of free will and determinism in a little bit more detail. This is just a quick, brief introduction to this topic. There is so much more literature that we could look at to explain and go into a lot more precise detail on different kind of areas of free will. And when we make a more in-depth course on free will, we will do this in a lot more detail. So I hope you've enjoyed this course. Feel free to check out any of the other courses on this page, and feel free to give a review to see where we might want to improve, see where we've done well, see where we want to improve exactly. So I hope if everybody has enjoyed this, and see you in another course.